Um, we're about to start getting into the discussion of um, looking at objects in motion. It's the first thing we generally do in physics. We see something moving, we want to analyze the movement, the distances traveled, the rates of movement, and so forth. Um, and as the year progresses, we're going to use movement or changes in movement to tell us more about forces involved, a concept called energy, a concept called momentum. So this is the start. And one of the first places we have to start is called displacement. And we have to be careful of making the differences between displacement and distance traveled by an object. We have to clarify that. What's the difference between the two terms? Sometimes students think of the terms as interchangeable, and they are not. So let's talk about this. We have a scenario where maybe you're at home, and maybe you're going to walk over to school. And let's say the distance between those two particular places is 2 kilometers, a little over a mile. So it's a nice little walk, good exercise. Well, if we look at this a little more scientifically, especially within the context of the concept displacement, we need to know what our starting point is. We need to know what our ending point is. We need to use an appropriate measurement scale. And we really have to be concerned with direction. What direction is the motion happening? So one of the first things you want to do when you talk about any motion is say, okay, I'm going to look at that motion from this place to this place. So we need a starting point. We need a 0 point. So, and think of that kind of like a graph. You need an origin, if you will. So I'm going to call the student at home. I'm going to call where they're standing before they begin their trip. I'm going to call that the origin. I'm going to call that 0. And what that means is that the student is going to travel along an axis, right? We're going to travel this way, 1 kilometer, 2 kilometer, and so forth. And we can actually label that as being positive. And I may be so bold as saying, you know what, I'm going to kind of think of this as in a mathematical way, which is where we're going. So I'm going to think of this as positive x direction. Sometimes we don't think of it as positive x direction. Sometimes we'll think of this as cardinal directional systems, like north, south, east, and west. So some problems may say, well, positive x, maybe it's to the east, maybe it's to the north, who knows, the problem would define it, the scenario would be given. So if the student walks from here to here, they'll walk 2 kilometers. The idea of displacement, which typically in physics is denoted as delta x or delta y, a change in distance is denoted by, displacement is change in position, typically denoted by x or y. If you're moving sideways, it's typically x. If you're moving up and down, it's typically y. And that's defined as, well, what's my final spot minus my initial spot? Actually, let me back up. Some books use a subscript of little 0 and 1 to show initial position and final position. Some books will use 2 and 1, saying the same thing. Some books will use F and I, final and initial. I tell you the truth, depending on my mood, I'll switch from term to term to term. So just follow along. For this one, I'll go 2 and 1. Typically, that's pretty easy. So look, In this case, you started at position 1, you were at the origin, and you ended up over here at the 2 meter mark. And so the displacement becomes 2 minus 0. Well, if I'm really diligent about this, 2.0 minus 0 equals 2.0 kilometers. Now, that's technically positive. So that direction of motion is important with displacement. I moved in the positive direction. I moved along the positive number line. If instead of the positive, you're using the direction, you can replace that with saying, well, I moved 2 kilometers east. Okay, no big deal. Now, if I walk to the school and then I want to turn around and walk back, well, if I analyze the walk back, this changes. Because even though I'm going to walk another 2 kilometers, that's pretty evident, the displacement is different than the previous example. Because you are not walking the same distance in the same direction. As a matter of fact, once you define your what we call reference frame, how are we going to analyze the motion? What are our anchor points? And once you decide on those anchor points, once you decide on the scale, then you're gonna keep that analysis for that motion, for that for that entire situation. So if I walk back home, but this reference frame is still in play, this changes. Now instead of going from my home to school, I'm going from the school back to home. And what this does, I end up final minus initial. Well, if I started at school and walked back home, my initial position, where I physically start from, was here. And then if I walk back home, I end up here. That changes this, because I end up at home, which we called the origin earlier, and I started from the school. And what that does is changes my result. Instead of moving positive 2 kilometers, I move negative 2 kilometers, which in layman's terms means you move backwards. Right? Instead of moving that way, you went that way. The other way to say that, of course, if I went east one direction, then in fact and indeed I probably went west on the return home. So there's 2 possible answers there. Now, that's much different and more mathematical and more stringent than distance. Distance is how far you went along the pathway during your travel, and is really independent of direction. And we're going to go over more examples of this over the next, several minutes. But in the first case, if you went from home to school, your distance traveled was just 2 kilometers. You walked 2 kilometers. You know that because your feet feel 2 kilometers. Your feet don't care about the direction. They just feel like they've walked. When you return home from school, it is again another 2 kilometers. You travel that pathway, independent of direction. You feel that in your feet. Now, we've defined these scenarios as going from home to school and from school to home. What if we look at the entire round trip as one event? Instead of two separate events, the entire round trip is one event. Then it gets interesting. If I consider the entire round trip as one event, well, if I start at home, walk to school, and walk back, and I consider that all one round trip. Well, my starting position is here at home. I walk to school, then I walk back. And if I frame it in that way, well, then my final position is also home. And if that's the case, my displacement goes from zero, well, I should say from zero, from home back to home. And your displacement is nothing. A physicist would say, you didn't go anywhere because you started in one place and you ended back at the same place. No change in position after this event. That's much different than distance. Distance, your feet feel it. You went 2 kilometers and then you went 2 kilometers back. So the length of the entire pathway would be the 2 kilometers and the 2 kilometers, 4 total kilometers. I hope that makes sense. We're going to talk about other examples when we walk, not just on a number line, and we're going to talk about examples when we end up going into the quote-unquote negative part of the number line. Because when you make that zero origin, all distances are going to be measured from there. So if you walk backwards, we got to talk about negative displacement. Be right back.